position, not velocity. So it's going to increase and then decrease. Drone is from 2.4 meters, speed of 1.5. So delta y equals 2.4. Change in y. So v of 0 is equal to 1.5 horizontally. So we have one vector going this way at 1.5, one vector going here at v equals 0, acceleration equals 9.8. What is the horizontal displacement? Okay. So from up to down, what is this displacement? Oh, is it talking about this? That line. So if we're going to find a curve, it would be y prime squared plus x prime squared. Is that what we're trying to find? No, it's just horizontal. So horizontally, what is this delta x? We know that. Okay, so first we're going to find time. So we're going to say time. Let's see, we're going to have. So we have delta y is equal to 2.4, acceleration is 9.8, and v naught is 0. We find time. So finding time. So we have change in x, acceleration, and v naught. So that'll be, was it delta y is equal to v naught times t plus 1/2 acceleration 9.8 t squared. It's not on here. And so we can calculate that to be 2.4 is equal to 0 plus t squared 9.8 over 4.9 square root. So we have the square root of 2.4 divided by 4.9. That's not right. 0.7. 0.7 is equal to time. Okay. Which makes a little sense. Find the horizontal displacement. Okay. So now I know that the time equals 0.7. It's horizontally from a speed of 1.5. Okay, so if time is equal to 0.7, v naught is equal to 0, or is equal to 1.5, acceleration is equal to 0, and try to find delta x. So we know delta x is going to be equal to v naught, so 1.5 times 0.7 plus 1/2 acceleration, which is 0, t squared, so all that doesn't matter. So 1.5 times 0.7 should be your answer. Times 3 significant digits, 1.05. We have gone big foot right with my abbreviated, yeah. A stone is thrown upwards. Hey. edge of a cliff with a speed of 3. Okay, so we have stone, we throw it upwards. So V0 is equal to 3. It lands on the ground with an impact speed of 6. So V equals 6. But -6 because it's hitting the ground. It goes up and then it goes back down. Acceleration is equal to -9.8. How long was trying? How long was we trying to find t? So the kinematic equation is v is equal to v0 plus acceleration times time. So we're trying to find the acceleration velocity using acceleration times time. And this is the delta. So we have velocity is 3, so we have 3. 3 is equal to, or no, 6. -6 equals to 3 plus 9.8 t, subtract 3, -9, divided by 9.8. Let's put that as a positive because you can't have a negative time. Yeah. And which up is positive. Yeah, so up is positive, so negative. That has to be negative. -9 divided by 9. Yeah, so we get 9 over 9.8. Does that make sense? 0.9 around 1 second. That seems a little too fast. Let's look at our information. So this is the equation we want. 9.8 times t plus initial is 3 is equal to 6, impact speed of 6. Ah, I see. We're going to make this negative. We have negative 9.8. So plus a negative 9.8 to a negative 3. So we get -9. Ah, that's where I missed out. It goes -9.8. Negatives cancel. And we get 9 divided by 9.8. 0.9 to 2 significant. 9.2. Or 0.92. So we'll check this. Yeah, 0.0. Yeah, that sounds reasonable. A water balloon is tossed straight up at time t equals 0. Okay. Which of the following functions represents a graph of the velocity of a balloon as a function of time? Okay, so we're gonna have acceleration, so we're gonna have a change in. So acceleration is equal to 9.8. V0 is equal to positive number, not integer, positive number. And so we're going to see something like this. The ball goes up, hits a point, and then goes back down. And so over time, this happens. So velocity should have a constant acceleration. It goes up. It should go up, right? Velocity goes up, and then it goes back down. That seems to be right. Not like one compound does, pushes the pointer like that. Anyway, you have 9, so you have a constant velocity, slope is constant. This goes up, hits a point, which is that intercept right here, the apogee, and comes down. So that's wrong, that's wrong, that's wrong. The graph below shows the velocity as a function of time for two marbles, A and B, rolling across a table. Which statement about this two-object system is correct? Marble A and marble B have the same acceleration. So this is velocity and time. So acceleration is change in velocity. It's velocity prime. So let's see. They seem to have 2 to 1, 0 to 2, at the same time interval. That seems to be correct. They have the same acceleration. I don't know if it's 0.5. Let's test that. So we have 0.5 per what? They have over everything, not only at that. So I'm going to assume that's wrong. We'll go back to it though. It's a gray. We'll put that in yellow. Put that in yellow. Okay, let's look at red. In the first 5 seconds, marble B travels farther than marble A. Yes, this one has a higher velocity. So I'd say that's correct. No. B should be correct. I'm gonna double check this though. Spent 15 minutes already, don't want to make a stupid mistake. 19. Should have the same acceleration. So, at 0.5 seconds. This one's going down. No, this one's wrong because one of them is negative and one of them is positive. No. During the first 0.5 seconds, marble B travels farther than marble A. So it certainly has a higher velocity right here. The area under this curve is bigger than the area under this curve right here. No, because that can't be right. A race car initially is at the starting line. Okay. Maximum acceleration. 25 minutes in time. Okay. How far will the car be tracked down at time 2? Okay, so you have race car is going. So we have V naught is equal to 0. Acceleration is equal to some arbitrary constant. We'll call that X. Time is another arbitrary constant. We'll call that Y. Where, and then the change, delta X, is equal to 25. So, how far? So we're going to have 25 plus a formula. I'll put that formula right here. Equals our answer. It would be, the first we have to find the change in distance and time. So we're going to put that time into an arbitrary constant. Let's call that 10. So time equals 10. So if we have the physics information reference sheet, we get V is equal to V naught plus A of t. V equals V naught A of t. If we put time as 10, we get 10 is equal to A. Now let's choose another one. I don't like that one. We have delta tx. So let's see, we have delta x is equal to velocity naught times t. So we'll put that number as t over 2, and then the average velocity v over v naught. So acceleration is constant. So if we use the original formula, we can find of v equals v naught. If v naught is equal to 0, v has to be equal to a times t. We'll put we should have delta x is equal to v naught t plus 1/2 a t squared. That's it. So v naught is equal to 0. So if delta t is equal to 1/2 and then our acceleration sort of change would be the average of the so that would be delta x is equal to, that's 1/2 10 is our time squared, just an arbitrary number. 25, 50 over 100 is equal to a. Sure. So a is equal to 1/2. Where time equals 10, and I think that's the only thing I assumed. Equal to a. I'll show you a paper. So we get time equals delta t is equal to v naught t plus 1/2 a t squared. 25 is equal to 0 times t, which is still 0, plus 1/2 a. We'll put a to be a number, and we'll put t to be 10. And so we get, multiply across, we get 50, 50 over 100, 50 over 100 equals a. So that a is equal to 1/2 time is equal to 10. What happens at time equals 20? Delta x is equal to 25. V naught is equal to 0. Find that t is equal to 20. What is v, or the change in x? Cool. So we have change in x. Change in x is going to be v naught. That's still 0. Plus 1/2. In this example, we're going to have time is going to be equal to 20. 20 squared. A is equal to 1/2. So we get 400 over 4. That's delta x is equal to 100. This should be right. Yay! Cyclists accelerate from rest to a velocity of 8 meters per second. So we have V naught is equal to 0, V equals 8, over T equals 23. What is the magnitude of their displacement? What is the magnitude? How much did they displace? So, let's look at this. We have inline acceleration, and then using that we can find trying to find delta t max. That's a question mark. Using the original equation, we can use v is equal to acceleration times time. So acceleration is also known. So v is equal to 8. We have 8 equals at. 8 is equal to 23a. A equals 8 over 23. Cool. So A is equal to 8 over 23. Cool. Now we have the change in x. We have delta x is going to be equal to velocity. So v times time delta x is going to be wait, might even not need acceleration. Delta x is equal to v, which would be 8, plus v naught is equal to 0 times time. Time is 23. Is that all they need? Yeah. Okay, just overcomplicate this. So it's 4 times 23. That's 112. 12 meters. I think I overcomplicated that. I did 4 times 27. 27 times 4. Like 28, yeah. Math was off. Oh, okay. Good job. 92. Balls kicked with an negligible air resistance. What's the magnitude of the vertical velocity at point P? We have point P. I see, okay. So it has that velocity. Actually has 2 vectors right now. A few vectors actually. So we have one of the velocity going this way, one pushing it this way. So what's the magnitude? It's going to be decreasing because you have a stronger acceleration. This is x, but this is x squared. Now so you have this acceleration right here. So the velocity is, how's the velocity changing? So it's acceleration. Acceleration is negative. So it's going to be decreasing. Right? I think there's enough information. Not, it's changing. You'll think of this though. So we're looking at vertical velocity, not here. So we have vertical, it's going up, should be decreasing, because if we look at this as just without any of delta y, you should see this. And it's slowing down right now. The vertical velocity is slowing down, it's decreasing, because you have negative 9.8 acceleration. I think I'm right. Hopefully I'm not. Yay!